Okay, so here it is, the last concept for section 3.5, projectiles. We're going to talk about extending projectile concepts. So one of the first things that we need to remember that we know about projectiles is that projectiles are two-dimensional kinematics problems. Right? And that means that they have this vertical component and they have this horizontal component. Right? And a kinematic problem involves a vector. I used velocity vectors in our last example, so let's make this a displacement vector. Why not? And this displacement vector is made of an x component and a y component. And we could solve for this displacement vector, right? Let's say I know the displacement vector dx is 2 meters and dy is 6 meters. I could figure out both the magnitude and direction of the displacement vector. Well, first thing I'm going to do is I'm going to solve for the overall vector, so that's going to be 6 squared plus 2 squared is going to be 36 plus 4. Um, 6.3 meters. And I can also figure out the angle by taking the inverse tangent. So 6 divided by 2. And that's going to be a 71 or 72 degree angle. And so that means that that displacement vector is 6.3 meters at 72 degrees. Alright, so we understand that, but one of the things that we want to do is we want to make sure that we can apply the concepts in as many situations as possible. So let's take a look at that. Okay, so one of the things that we've looked at is that if you have projectile motion, right, you've got an object, it's falling off of a surface, right, you can break that down into vertical and horizontal motion. Right, and that means that any point along the way, that point here, or this point here, or this point here, right, you can solve for it. Right, all we need is we need to establish some values, right, where we know that the height that something falls from in the vertical direction would be a y value, and the displacement in the x direction would be an x value, and that the velocity is tangential to the pathway the projectile is traveling in. And we know because it's given some vertical velocity that is not equal to 0, and because it fell off of the edge, we say that the velocity in the y direction is also is actually equal to 0. And we say that in this situation that the velocity at any point, point 1, point 2, or point 3, is going to be equal to negative gt, and that the position at any point along the way is going to be related to 1/2 gt squared. And that in the horizontal direction, the position is related to the velocity times time. And the connecting point between these two is time. The time is the same for both of them. And so that's pretty simple, but this is only true when an object is launched off of an object, right? When its initial velocity is 0. What happens when the initial velocity in the y direction does not equal 0? Well, let's first, before we do anything too intense, let's take a look at how or when that might happen. Let's say that Benny has a scorpion. Because we all know Benny has a scorpion. And let's say that Benny decides that he is going to flick that scorpion off of his hand. Alright, and for whatever reason, he's holding his hands way over his head. Alright, but Benny's going to flick that scorpion, and that scorpion is going to follow a projectile pathway like this. Alright, so that means that initially the object is going to have some velocity, and that some velocity is going to have a horizontal component and a vertical component and a horizontal component. So this is our situation. We know that the horizontal velocity does not equal 0, but now because it's getting flicked in an upward direction, the vertical velocity also does not equal 0. And so that means these equations that we were so happy to use before are not going to be valid in this situation, because these two equations were true because your initial velocity in the y direction was 0. But now your initial velocity in the y direction is not 0. So we can still break it down into its vertical and its horizontal components. But we cannot do much more than that. We cannot use those original equations. So what we can do is, we know that the relationship, the things that are happening from vertical are happening from free fall. So we know that we can still find the velocity at any point in the y direction. It's just that now it's going to be, and again, we can keep our axes the same, right? Where for the y direction, down is negative and up is positive. So it's given some non-zero positive initial velocity upward, and it's going to, that is going to change what the final velocity is depending on how long gravity has been acting. Alright, so we've just brought back the initial velocity component, and the same thing happens for position. Alright, because this value isn't 0, alright, we know that this relationship is going to be true. The position will change as a function of both the initial velocity and the acceleration due to gravity. And we keep these signs because we've established that down is negative. And in the horizontal, well, what's changed in the horizontal direction? Is there a force in the horizontal direction? No, there still is not a force in the horizontal direction, which means that there is still no acceleration in the horizontal direction. So that means that nothing has changed. X still equals v naught xt, or the velocity in the x direction times the time that it's in the air. So conceptually, what are a few things that this changes? Well, the first thing that this changes is if the object travels up before it travels down, that means it's going to be in the air longer, which means that if you give it some initial vertical velocity in the positive direction, these objects are going to be airborne longer. Alright, well, and we remember what's the relationship between these two? Is time. Now we know that since it's going to be in the air longer, that means that it's going to be able to travel further. And so we can think of some situations where this is of great benefit compared to just getting flicked off with no y component to the velocity. For example, let's say that u you've got some really rocking hair today. All right, let's say that you are here. Well, Benny can't share his scorpion with you if he just flicks it with only a horizontal component of velocity. He's got to give it some vertical velocity so that he can cause it to cover some distance over to you. Isn't that nice of Benny to share his scorpion? Sharing is caring. He's talking inside of your head again. And you are just so thrilled that his scorpion friend gets to come see you. So, without doing much problem solving here, we can see that there's quite a bit of similarity between these two concepts. The only difference is here it has no vertical velocity to begin with, and here it has a great deal of vertical velocity. And this still works even if something is initially given some sort of negative velocity. Right, here's Benny. And he could cause his little scorpion. He could give it some initial velocity where the y direction is negative, right? And then it would still be projected because it has some x component to its velocity, and these equations would still be valid. It's just that when you plug in your Vy initial, that's going to be a negative value that you plug in there to go with your negative GT. So your position will also be affected by that. Right, so it doesn't really matter if the initial velocity is positive or negative. It just, you plug in a negative value if the y component was downward, and you plug in a positive if the y component was upward. And understanding how those different values come about as a result of the initial velocity and what components of the initial velocity you're looking at are really going to help you when you begin problem solving with these projectile problems.